This question, it's interesting because it's asking for the derivative of an inverse of a trigonometry function. So for this equation, we can derive the formula for derivative of sine inverse x. We know that sine inverse x equals to y. So sine y equals to x. Now if we take the derivative of both sides, it becomes cosine y, and here we need to use the chain rule. So dy over dx equals to 1. So dy over dx equals to 1 over cosine y, which is also 1 over cosine sine inverse x because of the first equation. And then here we need to use a substitution. So we draw a triangle, a right triangle, 90 degrees. We let the hypotenuse be 1, and then let the opposite side be x, and here is theta. And if we use the Pythagorean theorem, we know that this side is square root 1 minus x squared. Now we know that theta equals to sine inverse x. This is because sine theta equals to what? We know that, so sine is O opposite over hypotenuse, so x over 1, which is x. So sine inverse x equals to theta. And then cosine theta equals to adjacent over hypotenuse, so this over this, which gives us 1 minus x squared. Now we can see that theta equals to sine inverse x, and then cosine theta equals to this. So we substitute the theta into here. Cosine sine inverse x equals to square root 1 minus x squared. And then we can see that this is the same as this. So the derivative of sine inverse x equals to 1 over 1 minus x squared. Now if we use the formula to solve this question, dy over dx equals to 1 over square root 1 minus x squared minus square root 1 minus x squared. And then if we simplify this, square root we change the denominator so that it's the same, and then that gives us 1 minus 1 plus x squared over square root 1 minus x squared, and this cancels out, so it becomes x squared over square root 1 minus x squared. So this is our answer, which is D.